Hello everyone, welcome back to my channel. I'm Fo. And today we're going to create a video about the infrared IR obstacle avoidance sensor module. The infrared IR obstacle avoidance sensor module is a key component in many robotics and automation projects. It is used to detect obstacles and avoid collisions by emitting infrared light and measuring the reflection of nearby objects. Here's an overview of its features, working principle, and how to use it in your projects. Features: adjustable detection distance. The sensor module typically has a potentiometer that allows you to adjust the sensitivity and detection range. Digital output provides a high or low signal based on the presence of an obstacle. LED indicators often includes LEDs to indicate power status and obstacle detection. Operating voltage usually operates at 3.3 V to 5 V, making it compatible with most microcontrollers and development boards. Compact size, easy to integrate into various projects due to its small footprint. Working principle: the IR obstacle avoidance sensor module operates using an infrared LED and a photodiode. Here's how it works. Emission: the infrared LED emits a beam of infrared light. Reflection: when an obstacle is present within the detection range, the infrared light is reflected back towards the sensor. Detection: the photodiode detects the reflected IR light. If enough light is reflected back, it triggers the digital output to indicate the presence of an obstacle. Output: the module provides a digital output signal, usually high or low, based on the reflection detected by the photodiode. Using the IR obstacle avoidance sensor module. 1. Pin configuration. VCC: connect to the power supply, typically 3.3 V to 5 V. GND: connect to the ground. Out: digital output signal. It goes high or low when an obstacle is detected. 2. Adjusting the sensitivity. Use the onboard potentiometer to adjust the sensitivity and detection range of the sensor. Turning it clockwise usually increases the sensitivity, while turning it counterclockwise decreases it. 3. Connecting to a microcontroller, example, Arduino. Here's a simple example of connecting and using the sensor with an Arduino. Components needed: IR obstacle avoidance sensor module, Arduino board, breadboard and jumper wires. Wiring: VCC: connect to 5V pin on the Arduino. GND: connect to GND pin on the Arduino. Out: connect to any digital input pin on the Arduino, example, pin 2. 4. Applications: robotics, used in robots for obstacle detection and avoidance. Automation, useful in automated systems for detecting the presence of objects. Security systems, can be used in alarm systems to detect intruders. Line following robots can help in detecting the edges of a path.